4.2, 4.5, quiz review key. So in the first part, they ask us for each table determine whether the relationship is a linear function. If so, write an equation for the pattern. So for the first one, we look and our x values are changing by 1. That's what we want. So we look at the change in our y's. Well, the change in y's, we are adding 1 each time. And since this is a constant addition, we know that this is definitely linear. And then we have to recognize that this 1 is the slope of our line. So we start our equation. Y equals 1x. Then we have to determine what to add or subtract to the equation if necessary. So if we plugged in 0 for x here, we'd get 1 times 0 is 0. But our output for that value is supposed to be 2. So our equation has to have a plus 2 at the end. So our answer becomes y equals 1x plus 2. Question 2, we'll do the same thing. We look at the x values first. They go up by 1, so we're good. Then we're looking at the y values. Well, the change in the y values is plus 2, plus 2, plus 2. Since it's an addition and a constant addition, this is a linear function. And then remember that this value represents our slope. So y equals 2x. Then we have to figure out what to add. Well, 0 times 2 would be 0, but we need to get back to 5. So we'll add 5 here. For this one, let's go ahead and make these x and y instead of n and m. The x's are going up by 1 with the y's. It's going down by 3, down by 3, down by 3. So this is a constant subtraction, which still makes it linear. So it's still linear. That negative 3 then becomes your slope. So you've got y equals negative 3x. And then if we plugged in 0, you get negative 3 times 0 is 0, but we're supposed to be at 1. So our equation needs to have a plus 1 at the end. So y equals negative 3x plus 1. Question 4, same idea. Our x's are going up by 1, which is great. Our y values, well, here they're adding 1, then they added 3, then they added 5. Notice that this is not constant. These are all different, so this is nonlinear. Question 5, our x's are going up by 1, so we're good. Then we look at the change. They are going up 6, and up 6. So they're adding 6 each time. That's constant, so this is linear. And then that 6 becomes your slope. So y equals 6x. And I know it's going to be minus 4. Question 6, it says each ordered pair represents a function. Write a rule that represents the function. And so we look at the x values increasing by 1, so we're good there. Then we look at the y's. From 1 to 5, that's plus 4. But then 5 to 25 is not plus 4. So something else is taking place here. Well, they're multiplying by 5, I think. 25 times 5 is 125, so they're multiplying. And then 125 times 5 is 625. So this is a special case, and anytime we're multiplying by a number consistently through our function, we're going to take y equals the number we're multiplying by raised to the x power. So y equals 5 to the x power. Question 7, our x's are going up by 1. That's good. From 0 to 1, they added 1. From 1 to 4, they add 3. From 4 to 9, they added 5. And from 9 to 16, they added 7. So this is another special case. This pattern is random. It's not consistent. So anytime that happens, that's when you start testing y equals x squared, y equals x cubed, and we've got to figure out which one works, and so on. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So we found the one that wins. The correct equation is y equals x squared. Question 8, our x's are going up by 1. Then our y's are going plus 3, plus 3, plus 3, and then plus 3. So that's a constant addition of 3. So that means this is going to be y equals 3x. And then if we go back to the beginning, it'd be minus 2. So y equals 3x minus 2. Here it wants us to graph each function tell whether the graph is continuous or discrete. We're not going to worry about graphing it. We're just going to know from reading it whether or not it's continuous or discrete. The cost C of movies, M, I buy, can be written by the equation C equals 7M. Well, they're talking about cost, which is money, but the input is the movies. When you buy movies, you can only buy whole movies. You can't buy a half a movie. Since you can't break apart the movies, this is discrete. Question 10. The price P in dollars for apples depends on the weight in pounds of the apples. So you've got price and then weight. Well, weight is your input, and so we know weight can be listed as a decimal, so this is going to be continuous. In question 11, 12, and 13, and 14, they want us to graph the functions. And so remember, when we graph these, we test from -2, or we use points from -2 to 2 normally. So we'll use those points here to graph. So we use from -2 to 2 as our points to test. So for number 11, if you plug in -2 here, you get -12 back out. -1, you'll get -7. 0 is -2, and then you've got 3, and then 8. We're not going to be able to fit all these points on the graph, but we can get enough to get an idea of what our graph looks like. So we've got 0, -2, 1, 3. I can get 2, 8, almost on there. And then -1, -7. All right, so I've got my points, and so my graph should look something like this. We'll do the same thing for 12. We're going to plug in the negative value and then evaluate the expression for y to find our point. So when you plug in -2, you get 5, a positive 5 out, because the absolute value makes it positive. And then here we'll get 4, we get 3, we get 4, and we get 5. So our graph looks somewhat like this. And remember, absolute value is a V-shaped graph. So our graph looks like this. (13), same idea, we plug in the values. -2 squared is 4, but then they have the negative outside, which we account for, so this becomes -6. -1 squared is 1, and then you tack on the negative again, so we get -3. This would be -2, and then 1, you've got -3, and then -6. If you're confused as to how I'm getting these values, remember, it's negative, and then you're plugging in, let's say, -2, squaring that, -2. The negative that's outside here stays outside until the end after you've squared whatever you plugged in for x. So -2 squared is 4, but then you tack the negative on again before you subtract the -2 from it to end the problem. So if we plot the points, we've got -2, -1, -1, 1, and then we've got -2. Not far enough. And so our graph looks something like this. And remember, parabolas are U-shaped. In this case, the U is upside down. And so that's our graph. 14, same idea, plug in the negative. So -2 with a negative outside cancels out the negative to become a +2. So we get 2 plus 3 is 5. -1 with the already negative outside gives us a +1, so we get 4. Here we get 3, 2, and 1. So we plot our points. So -2, 5, -1, 4, 0, 3, 1, 2, and 2, 1. And so these are our points. So we connect our points, and this is our line. Write a function rule that represents each sentence. So for the top part, we're going to write a function rule here. 8 less than 1/3 of x is y. So we've got 1/3 x, and then 8 less than it would be minus. equals y. I'm not going to write these in function notation yet. I'm just going to write these out as I read them. Z is 6 more than twice y. So z equals 6 plus 2y. And remember, as you're writing these, the word is a great indicator of where your equal sign is. 3 more than 8 times a number is b, or number a is b. So 3 more than 8 times a number a is b. So the equal sign shows up with the is. All right, for 18, we're going to write a function rule. This time we're going to use function notation. The price P of a large pizza, or cheese pizza, is $7.95 plus 75 cents for each topping T. How much is a pizza with 4 toppings? So we've got P of T, and remember this is just a single variable. It's just written fancy in function notation, equals $7.95 plus 0.75 T. And so what we're going to do is we're going to plug 4 in for this. So we've got P of 4, which just means we're plugging in 4 for T. So we've got 7.95 plus 0.75 times 4. And we're going to figure out what that equals. And in this case, when you multiply the take the 7.95 plus 0.75 times 4, you get that the pizza costs a total of $10.95 with 4 toppings. All right, 19. Jacqueline's earnings M's are a function of the number of lawns N she mows at a rate of $12 per lawn. How much did she earn if she mowed 7 lawns? So first thing we gotta do is write our function rule, our function notation rule. So her earnings M is the output, so we have M of N equals 12 times the number of lawns she mowed. Well, they want to know if she mowed 7 lawns, how much money did she make, essentially. So 12 times 7. And so she made $84. The total fees F of a book club membership are $12.50 per month and a one-time administrative fee of $4.75. What is the amount of fees for 5-month membership? All right, so we've got F of M, because the fees is the dependent, M is the independent, so it's the input. We've got $12.50 per month, plus the administrative fee of $4.75. And here they want to know what's the cost going to be for a 5-month membership. So we're plugging in 5 for M. So we've got $12.50 times 5 plus $4.75. And so you get that the membership costs $67.25. Eric is 2 years younger than 2 times his sister's age. Write a rule that represents Eric's age A as a function of his sister's age S. So Eric's age is the dependent and his sister's age is the input. We know that Eric is 2 years younger than 2 times his sister's age. So 2S minus 2. How old is Eric if his sister is 11? So that means we're plugging in 11 for S. So 2 times 11 minus 2 gives us that Eric is 20 years old. And then last but not least, we've got write a function rule for the area of a rectangle whose length is 6 feet more than its width. What is the area of the rectangle when its width is 12? All right, so this one's a little harder to write as a function rule, but we should know the area of a rectangle whose length is 6 more than its width. Basically, what they're trying to get across here is area we should know equals length times width, but they're telling us here that the length is 6 more than the width. So we can change this. It's going to be area equals width times width plus 6. We change the length into what the length represents. It is 6 more than its width. All right, and so now if the width is 12, we got to figure out what the area would be. Well, the area is going to equal 12 times 12 plus 6, Well, 12 plus 6 is 18. So 18 times 12 would give us our area. And in this case, our area is 216 feet squared.